All right. Calculate the current in the copper cable, right? And let's see, and a heater it's 8.5 kilowatts when connected to a 240 volt electrical supply, okay? And so what did I do? 8 kilowatts. We got the voltage, right? So the first thing I did was I figured out the resistance, right? So power is V squared over R, right? I don't know if this is the best way to do it, but this is what I did, right? Power is V squared over R. We know the power, we know the V, so then we can figure out R, right? And then after that, I did current is voltage divided by resistance, right? And then I got the current, okay? And the question is whether we need to, and this is I'm using for the heater, right? The question is, do we need to take into account the resistance of the cable? The cable's resistance is very small, so, and since it's after that, I decided that in this case we didn't need to incorporate that, right? So then it says calculate the resistance. This is a resistivity thing, right? So resistance is going to be resistivity times length over the area, right? They tell you the area, cross-sectional area of the cable is 6 millimeters squared, right? But you've got to turn 6 millimeters squared into square meters, right? Okay. So remember that a square meter is 1,000 millimeters by 1,000 millimeters, right? Okay. So that this is really 6 times 10 to the minus 6th square meters, right? This is very, very critical. Okay. They're trying to mess you up there, right? Then the resistivity they give you, so just use that, right? And then the length of the cable they give you, so just use that, right? So calculate the resistance, we're good. And I got something that's like around 0.03, I'm just going to say, okay? Then it says calculate the power dissipated in the cable, right? So you've got the current here, which is somewhere between 30 and 40 amps, okay? Calculate the power dissipated in the cable. I'm going to use P as I squared R. And the resistance is this resistance, right? So whatever that resistance is, pop it down in there. Use this current here that's between 30 and 40, right? Okay. Then it says, in terms of the electrons, what happens to the resistance of the cable as the temperature of the cable increases, right? Remember, as the temperature increases, what the atoms move faster. There's increased collisions with the electrons, right? The fast-moving atoms hinder the motion of the electrons, and the drift velocity of the electrons is decreased. I missed that mark. Okay, so the electrons are drifting down that wire, and it decreases their drift velocity. If we decrease the drift velocity, we increase the resistance, right? So typically with wires, the resistance will increase with temperature. Semiconductors, by the way, do something funky. I think like at some temperatures, they actually decrease their resistance, which is counterintuitive. It's also bad because it's called thermal runaway, right? If a semiconductor gets too much current through it, the resistance goes down, so more current flows, and then it gets hotter, and the resistance goes down farther, right? Okay, and then the heater, this is just like our 18.1, right? Changes the temperature of water by 35 kelvins. The heat capacity is 4,200, right? Determine the rate at which water flows through the shower, right? So in 1 second, remember this is 85 kilowatts, right? That's our power is 85 kilowatts. So in 1 second, this is what I do, right? In 1 second, it's 8,500 joules, right? 8.5 kilowatts, right? Okay, so then you just set 8,500 equal to MCAT, right? And they give you C, they give you delta T, and you figure out the mass, right? And then it says state an appropriate unit for your answer, right? The mass is going to be kilograms, but this is in 1 second, right? That's 8,500 joules per second. That's what watts are, right? 8,500 watts, right? So it's going to be kilograms per second. Remember, though, that when you say per in the IB lands, right, meters per second is properly written this way. I'm not sure you'll get points if they say indicate proper units for velocity and you give them this. I'm not certain that they'll give you credit for it. I know they will for this, right? So let's go for this, right? So should be kilograms per second. Write it like that, okay? Only use kilograms. All right, I think we're good.